Hey guys, how's it going? So today what we're going to try to do is we're going to try to develop a new way to measure angles. Okay? So just like we have centimeters versus inches when we try to measure distance, we also have two different ways to measure angles. Okay? So far we've been working in degrees, and we know that all the way around a circle is 360 degrees, right? So all the way around is 360 degrees. Okay? Now, what we want to do is we want to translate that to a different type of measure, and the measure is called radians. Okay? Now, this radians idea actually makes even more sense than in degrees. Okay? Now, the reason is, imagine that this circle here had a radius of 1 centimeter. Okay? So if it's got a radius of 1 centimeter, what's the distance all the way around the circle? First of all, what do we call that? Well, remember we call it the circumference. And how do we calculate it? Well, the circumference is 2 pi r, right? Or in this case, it's 2 pi. Okay? So in essence, if I draw a little circle, it doesn't matter how big this circle is, but if I draw a circle inside it, right, I can say that the distance around it, as long as I make the radius 1 centimeter, right, the distance around it is 2 pi. All right? Well, what that means is that actually there's 2 pi of what we call radians to go around the circle. So 2 pi radians is the same as 360 degrees. Okay? So the conversion, just like 1 centimeter is equal to 2.54 inches, right? 2 pi radians is 360 degrees. Okay? Now remember, pi is the number 3.14159 and so on. Okay, so I'm going to show you a couple of different ways to think about this because I know that it's a new concept for you guys, right? But the main idea is that 360 degrees is a full circle, as is 2 pi radians. All right, so now let's take a look at why they're called radians. Okay. Well, here I've got something with a radius, I'm going to call it r. Okay? So imagine that I take another radius, right, and I draw another radius here, okay, but I don't put it anywhere. I put it at a very specific place so that this distance here is also the radius. Okay? So if I pick an angle, I pick an exact angle so that this distance here is the same as the radius of a circle. In here, so that angle right there is what we call 1 radian. Okay, so that's why it's called a radian, because if you turn on a radian, the distance that you get here is the actual radius of your circle. All right, so 1 radian is what we get when we turn the distance of one circle. And now, what's the total distance around here? You guys remember the total distance around there is 2 pi. 2 pi r, right? So if this is 2 pi r, right, then how many radians did we have to turn? Well, 1 radian gets me r, right? So to get 2 pi r, I have to turn 2 pi radians, right? So that means that if I want to turn all the way around, right, I know that the distance all the way around is 2 pi r. That means that the distance from here to here is 2 pi. Okay, so this is 2 pi radians. Okay, all right. So the next thing we want to look at is how many radians is it to get halfway across a circle? Okay, so we know all the way around is 2 pi radians. What about halfway? So what about just that? Well, if this here is 2 pi radians, halfway around will be half of that, right? So that would be 1/2 of 2 pi, which is pi radians. So the short form is rads. Alright, so pi radians. Okay, now what we want to do is we want to figure out how to convert back and forth from radians to degrees and degrees to radians. Okay, because we want to know how to compare those two. Okay, so what I want to show you is this page right here. Okay, now what I'm going to do is I'm going to stop for a second and I'm going to let you guys collect your blue sheets from your supply teacher. Okay, so you can pause the video right now, hand out the blue sheets, and then we'll continue. Okay, so now you guys have all got your blue sheets. On the back, you have a diagram that's a lot like this, right? And it's asking you to label all of these angles here with radians as well as degrees. Okay, so that's a lot. Now, what I'm going to tell you is that always, whenever we start dealing with, whenever we deal with angles, this line right here is what we call 0 degrees. Okay, or it's also 0 radians. Alright, so that's 0. Now, let's pick an easy one first. Alright, so we'll do this quadrant here together, and then you guys will do the other 3 on your own. We call this quadrant number 1. We call this quadrant number 2, quadrant number 3, and quadrant number 4. Alright, so we can take an angle to go anywhere in the circle, right, within quadrant 1, 2, 3, or 4. Alright, so now let's look at degrees and radians. Okay, so first, let's look at an easy one. Let's pick this right angle. Alright, so we know that that's 90 degrees. Okay, so this here is 90 degrees. Okay, now what I want to know is what's 90 degrees in radians. Alright, well what we're going to do is we're going to set up a proportion. Okay, so the trick is that out of 360 degrees, we have 90 degrees. Okay, and now 360 is the total, and you remember that in total we have 2 pi radians. Okay, and the question is 90 degrees out of 360 is we don't know how many radians out of 2 pi. So I'm going to put a little x there, right? And now we need to solve. So all we do is we cross multiply and we'll figure out what x is, right? So x is 2 pi times 90 divided by 360. Okay? Right? So that actually ends up being pi by 2. Alright? So what we've just figured out is that 90 degrees is the same as pi by 2 radians. Okay? Alright, let's try another one. So let's say we pick this angle right here. Okay, well that angle right there seems to be halfway between 0 and 90, which means that it's 45 degrees. Okay, so that one's 45 degrees. Now let's see how we convert 45 degrees in radians. Alright, so we've got 45 degrees out of 360 is equal to, we don't know how many radians out of 2 pi. Okay, so again we're going to cross multiply, so we'll end up with 2 pi times 45 divided by 360, right, and that's x. So we end up with x is pi by 4. Alright, so what we figured out is that 45 degrees is the same as pi by 4 radians. Alright, let's do one more on this quadrant. So let's do this one here. Okay, so this one looks like it's a third of the way between. Okay, so we'll call it 30 degrees. Okay, and the question is, how do we convert 30 degrees? Well, 30 out of 360 is the same as, we don't know what, out of 2 pi. Okay, so same deal. We cross multiply, and we're left with x is 2 pi times 30 out of 360. So we get the answer, x is pi by 6. Okay, so let's go back and make our conclusion. 30 degrees is the same as pi divided by 6 radians. Alright, so I'm going to let you do this one. So this one's 60. Okay, and then all these are multiples. So this would be 30 degrees from 90, so 120. This one would be 45 degrees from 90, so 135, and so on. So I'm going to let you do the rest. Okay, but what we want to do right now is we just want to practice a little bit more converting. Alright, so to express 30 degrees in radians, let's do that. So all we're going to do is we're going to set up our little ratio. So I know that we've already done this, but I just want to show you how it's very similar to go either way. Okay, so we're going to do that, and we'll solve, and as we found out before, it's pi by 6, right? So all we do is set up our ratio. 30 degrees out of 360 is x out of 2 pi. Okay, now what if I want to represent pi by 4 radians in degrees? Well, nothing really changes. It's just that now I know that pi by 4 is out of 2 pi, and what I don't know is what's it out of 360, right? So now I'm just trying to figure out the degrees. Okay, so again, we're going to cross multiply. Okay, so 360 times pi by 4, and then divided by 2 pi, and that's going to be x. Okay, so now let's simplify that. So 360 times pi divided by 4, the 4 cancels the 360, right? So the 360 divided by 4 is 90, so that gives us 90 pi over 2 pi is x. Pi's cancel each other out, and we get 90 divided by 2 is 45 degrees. Okay, so exactly the same process, right? Except now we know something that we didn't know before. Okay. All right. Now let's do one more thing. Draw a rough estimate of 7 pi by 4 and state which quadrant the angle ends in. All right. So let's say. So first I want to draw my 4 quadrants. Okay, so you're going to start every one of these questions like that. Draw your 4 quadrants. And the question is, where is 7 pi by 4? Okay, and we're going to state the quadrant. So 7 pi by 4. Now let's think about this. We know that the full circle is 2 pi. We know that that's pi. Okay, so this would be 4 pi by 4, right? So 4 quarters is 1 full pi, right? So that would be 4 pi by 4. And what do we need more? Well, we need 3 more quarters. So that means that we still need 3/4 of the way to the back. So we'll end up right there. There's our angle, 7 pi by 4. So 7 quarters, right? So that's 1/4 of pi, right? And I need 7 of those. There's 1, 2, 3, 4, 5, 6, 7. 7/4 pi. And which quadrant are we in? 1, 2, 3, quadrant number 4. All right. So 7 pi by 4 looks like that, and it ends in quadrant number 4. All right, that's it. You folks have a good weekend. Thanks for paying attention, and keep working on those blue sheets. All right, see you Monday.